Hello everyone, welcome to part 1 of solutions and mixtures. Look at the pictures in a few next slides. Can you tell what these substances are made of? Tea, water, sugar? That's correct. Now look at this yummy breakfast. Milk and cereal. That's correct. Raisin bread has dough, raisins, and there is evidence of bubbles of air if you see the little spaces in between. And this orange juice has water, sugar, and maybe added vitamins, sometimes even orange pulp. Can you divide them into categories? To do so, I want you to look at each and every picture. In here, it looks like there's only one phase, one liquid phase. But in reality, it's a mixture of many things. In here, the cereal looks like you have many mixed together. The milk and the cereal appear. In the juice, even though there are many things mixed in, you only really see one phase. And the last one, the raisin bread, you can see all kinds of different solid parts. So the first one, the tea and the orange, are into one category, and the raisin bread and cereal are another category. Let's look at them more closely. Here we are. The first category we call homogeneous mixtures, as in homo meaning one. You can only see one visible phase, one liquid phase. So even though we know that in these liquids there's a mixture of many things, it is not a pure substance, but only one appear, this is what we call homogeneous mixture. In the case where you see many different phases, we will call this heterogeneous mixtures. So in this case, you have liquid phase and solid phase that appear, and here you have two solid phases, the dough and the raisins. You can even say that you have gas because of the bubbles. Take the time to fill out the information on your paper. Mixtures can be separated into two categories, as we said previously: homogeneous, heterogeneous. Homogeneous, you can only see one phase. Heterogeneous, you can see many phases. If we go back to homogeneous, it is composed of two or more substances. It can only be a gas, liquid, or a solid. Here are some examples of homogeneous mixtures. Air. As you know, air is not pure. You have many different gases in the air. We know there's oxygen, there's nitrogen, there's carbon dioxide, there's water vapor, but for us, it all looks like one single phase. You have even a spoon is made of steel, which is a mixture of iron, carbon, and nickel. And you have a salty solution. It is made of salt and water, but you only see the liquid phase. There is salt in there, and the one way to tell is by tasting it. Now let's look at the heterogeneous mixture. It is composed of two or more substances. However, it may be a combination of solids, liquids, or gases, as opposed to homogeneous, where it's only one phase appearing. In this case, there's a combination of phases that appear. Here's an example: soft drinks. You'll see bubble of gas in a liquid phase. Piece of marble, you have mixture of solid phases. And raisin bread, as we saw before, is made of dough and raisins. Even gas is in the dough. So now let's guess Are the following substances homogeneous or heterogeneous? So that would be a soda drink. What do you think? You have liquid. You have gas. Heterogeneous, that's correct. Cup of coffee. What do you see? That is homogeneous, that's correct. Homogeneous because you only really see one phase. But in there we know there's a mixture of water, coffee grains, perhaps sugar. Look at your granite counters. This is visibly two solid phases, which means heterogeneous. Here's a close-up of the molecules inside the different mixtures. In the homogeneous mixtures, the particles are aligned equally, whereas in the heterogeneous mixture, the particles are all spread out differently. So homogeneous, the particles of different substances are uniformly distributed. The properties of mixtures are identical throughout the mixture. However, heterogeneous, the particles of different substances are not uniformly distributed, and the properties of mixture are not identical throughout the mixture. And that's it for part 1. Stay tuned for solutions, which is part 2 of this video.